Hey everyone, welcome to Data Cleaning and Transformation, Part 6, Finding and Handling Bad Data. So in this video, we're going to find some bad data, and then we're going to apply a fix to it so that it makes sense and that we can continue on with our smoothing and our modeling. So I haven't talked about what is the actual data yet, so I want to do that real quick. So Johns Hopkins supplies us with the cumulative total for all of its data, not the daily total. So all of these numbers that you see here are the cumulative total. So take a look at a country that has a little bit more volume like Belgium, and you can see that as the days go on, the number increases. So this is the cumulative total. It is not the daily total. If you want to find the daily total, you would subtract the day before from the current day and get that value. So one thing about these cumulative values is that they certainly should never decrease. And that's what we're going to talk about here. So for instance, if we have a value over here like 21,092, any value that comes after it should not be less than 21,092. That would certainly signal it is wrong. Now, there are some values in our data sets where that happens, and where somehow there must have been some sort of mistake, or for whatever reason, the values don't just increase daily. So you would get negative, deaths or negative cases if you were to try to find the daily values. Okay, so the way we can do this is by taking the cumulative max of each column. So what this is going to do, this cumulative max method, is that it's going to keep whatever the maximum that is seen from the top, from the very first value, that's what will show up over here as the current value. So the shape of this data frame is the exact same shape as our original data. And if the data is good, then this will be the exact same data frame. There will be no difference because the cumulative max for each column, and the way this works, it works column-wise, so it goes one column at a time. So it keeps track of the cumulative max for Albania is independent from the cumulative max of Algeria. So if the data is correct, then this will be the exact same data frame. The values will be the exact same, but that isn't the case. So here's how we're going to locate the bad data. So this first line simply just assigns the data set or the data frame its own variable name, make it a little bit easier to work with. So what we're going to do is, this is the original data. We're going to find out if it is less than the cumulative max. So if we go to our Belgium example, let's say there was a maximum, 10 days before someone entered in 23,000. So what this less than operator does here, it does it does a comparison to the exact same day in the other data set. So if the cumulative max was like 22,000 or whatever, and the current day was 21,092, well, then it would say, yes, that's bad data. It would end up as true. So this is going to create a data frame of Booleans, and it should be false everywhere, right? So the current day should not be less than the cumulative max up to that day. So this should all be false. And you can see that there's no visible trues here, but this is just 3 rows. We have several hundred days of data now. And so one thing you can do here to figure out which countries have bad days is to just call the sum method, which will sum up each column and trues evaluate as 1. So that will let us know if we have any bad data. And we actually see some bad data in a couple of the columns over here. So what we can do here is just sort this resulting series in descending order. And here I just output the top 10. So these are the countries with the most bad data. Now, if you look at the GitHub repository, you'll see that Spain actually is sort of a known problem for their data, and there's lots of discrepancies with Spain. So we're going to go ahead and examine Spain by itself. So what we're going to do is pull out the column as a series, pull out the column as a series from the bad data. So again, bad data is this Boolean data frame, and Spain is just one of the columns, somewhere over here, right? We're just going to pull out this column as a series, and then we're going to use it to filter itself. So wherever it's true, it'll come back as true. So there should be 86 values in this resulting series. So we're going to filter it, but we're just going to show the first 5. So here are the very first 5 bad values in Spain's data. So it begins on, the first bad value is May 25th. So what I've done here is I have manually entered in a section that we're going to look at so we can examine Spain's data. And this is from the original data set. So we're not going to look at the Boolean. We're going to look at the raw values that we have. And for these dates for the country Spain. So let's go ahead and look over here. So take a look at the values as they go down. And they are increasing until May 25th. And that's when you see a decrease. So this is where this is verifying that May 25th is bad. So the cumulative max up to this point was 28,752. And we see that it is less than that. So this is sort of an impossibility, right? You can't have, a couple thousand less deaths the next day. All right, so this is easier to see in a graph. And one thing I forgot to do was tell you to install matplotlib into the environment, the virtual environment. And that's because we don't use matplotlib in production. This is just for exploring the data here in the notebooks. So you'll need to go back to your terminal and install that if you want it to work. This line right here is using a style sheet I created. Just gives it just a little bit nicer style for the course. So you can inspect that on your own. All right, now we're going to plot it. So I'm going to take the Spanish data just for a month for the month of May. So again, this is the raw data. We're just going to plot it. And it makes it a lot easier to see. So this is the cumulative values again. And it's increasing until May 24th. And then May 25th, there's a drop. So this is the impossibility over here. And even though May 26th, there's a rise, there's an increase, it's still labeled as bad because it's lower than the previous maximum. So we're still going to label this as, as bad. And any dates that are less than this, right? So all of these dates over here are continuing to be bad. And maybe we should go to a little further, and you can see that it's still, but there's a jump here. So this is really strange. There's like completely flat data here that jumps on July 1st, and then it still looks like it's bad. Like there was 86 days, and then finally it eclipses its old maximum. So we're going to take care of this right here. We have to do something. All right, so the plan is simple. We're just going to do, what we're going to do is we're going to cover up any values that are lower than the cumulative max. So we're going to cover them up. Looks like it's probably these 86 consecutive days over here with missing values. And the way you do that in Pandas is with the mask method. And we're going to pass in this bad data. So let me make sure you see that again. So this Spain bad is just a series of Booleans of true or false, covering all of the time that we have. And we're going to send it to the mask method. So Spain is just the column of Spanish data. So I thought I pulled it out here. Okay, so I think I need to go ahead and pull this out. So let's say world deaths of Spain. Okay. All right, so this will mask it. That means it's going to make it NA, and then it's going to be stored in this new variable, Spain masked. And then all I'm doing here is I'm going to show you that it actually is missing. All right, so this is all we're doing is displaying that it is missing. So we have a lot of missing values over here. And so what we're going to do here is we're going to do some interpolation. And you know what? This will probably look, let me go ahead and show the, say, 2020 from 05, say 20, to 2020, 06, maybe like a month. So what happens here is that all I've done is I've covered up all of this bad data. So right at May 25th, I'm going to cover it up with this mask. So that's what this Spain mask is. And then, and maybe I can see where it might end. And let's see if we can look over here. So no, it's before that. Okay, here it is. So it ends on August 19th when it finally eclipses the last one. So all of these values are missing, those 86 values, and we're just going to fill them in. We're going to interpolate them. So we're just going to do some linear interpolation, which means we're just going to connect them by a straight line. Now, that's, obviously not the most elegant solution. Maybe we could try to do some modeling, or really try to dig into what happened is probably even better. But for our purposes right now, we're just going to do a simple interpolation and leave it as that. So what we're going to do here is we're going to take that new series, Spain mask, we're going to interpolate it. So that means from May 25th to August, was it like 19th or something? So from here, we're just going to make a line. So linear interpolation, and we're going to use those values. And then all I've done here is just plot it for now. So that gets rid of that, that dip. All right. So that's how we're going to cover up this bad data. And anyways, later on, we will be smoothing the data. So we'll find out we'll apply even more transformations to make the data look a little bit nicer. Okay, so how do you fix all the bad data at one point? So it's not too difficult. What you do is you find the bad data, which we're just going to call as mask. I used bad data before. Then we're going to mask the entire data frame. So here, instead of just working one column at a time like we do with Spain, we're just going to apply that mask to the entire data set. And then we're going to interpolate each column. And then just so we have actual numbers, not decimals, we're going to round it to the nearest integer and then force the whole data frame to become, all the columns are going to be integers. So let me go ahead and run this. And so this should do the fix for us. And you can't tell from here, this is just the last 3 rows. But now, and I call this world deaths fixed. Now this, I'm going to do the same call as I did above. So I'm going to check for bad data. So this is the check for bad data. And then I'm going to sum up everything. So I'm going to sum that Boolean data frame. The first sum sums up the columns. This next sum sums up that series. So it should be 0. And in fact, it's 0. So it looks like things are good. So it's got rid of the bad data. It might be a crude way, but it gets us over the hump and it takes care of this factor that would lead us into having negative deaths or negative daily cases. Okay, so let's write this function here to do this. And essentially it is just this right here. So we've already done it. I'm just going to copy and paste this. The only difference is that our variable is df. So I'm going to replace world deaths with df. And that should be it. So it's going to find the mask. Then it's going to mask it, interpolate, and then round it. And we're going to assign it back to df. And all we have to do is return df. And let's go ahead and run this function. So fix bad data. We'll say world deaths. And so that'll do all of those steps. Let's just, 2 lines of code and return our data frame. Okay. So That's it for this one. All we have to do is update our run function. So I'm going to go back up and copy and paste like I've been doing and just add that one more line. So here we go. Copy and paste it in the run. So we're up to 6. And so this is, well, step 5. So it is, what is it? Fix bad data and df, just like that. And again, we're going to call it just to verify that it works. And of course it, oh, what am I doing? 6. Run 6, so sorry. All right, there we go. So data world deaths dot head, and okay, looks like it worked. And we could say this is step 5. Okay, so that's it for finding and cleaning bad data. And that's the last major step here. We are going to encapsulate everything into a single class after this.